Welcome. This video is a continuation of a second video, and if you haven't seen it, you should be seeing a link pop up on the top right corner of your screen where you can watch the first part of this video. In the first part, we use the limit definition of the derivative to find the velocity of this position function. And in this part, we're going to use the limit definition of the derivative again to find the acceleration of this object. So the acceleration of this object is the first derivative of velocity. Using the limit definition, we have the limit as h approaches 0 of v of t plus h minus v of t divided by h. Now, as always, I'm going to challenge you to try the algebra on your own. So that is, try to figure out what v of t plus h is. Okay, now that you've paused your video, you should have this entire expression for v of t plus h just from plugging in t plus h into every spot where you see a t. Next, we also have a negative v of t, so take a moment and work out negative v of t. Okay, for negative v of t, we just made all of these negatives, so this positive became a negative, this one became positive, and so on. Now let's put this together. That is, let's rewrite this limit with this expression and this expression in the numerator as seen here divided by h. So your limit should look like this. And lots of things will become 0. We have a negative 24t and a positive 24t, a positive 45 and a negative 45, as well as a positive 3t squared and a negative 3t squared. Now, the remaining things that didn't sum to 0, so these terms all have an h. So in the next step, rewrite this with the h factored out. This is what your limit should look like now. We have a factor of h in the numerator and 1 in the denominator, so this just becomes 1. And we're left with the limit as h approaches 0 of 6t plus h minus 24. Applying the direct substitution property, we're just left with 6t minus 24. So the first derivative of velocity, which is the acceleration, is equal to 6t minus 24. I hope you found this video helpful.